So, hello students, we are going to see three-phase voltage source inverter with 120-degree conduction mode. Okay. So, here in the earlier class we have seen 180-degree conduction mode of the switch. In this mode we are going to see the switch will conduct for 120 degrees. Okay. So, here we will be having 6 switches because we are operating three-phase inverter S1 to 6. So, S1, 3, 5 are upper group switch, S2, 4, 6 are lower group switches. Okay. So, we are going to see, so if S1 is started at 0 degrees like this. Okay. So, I am denoting the switches here. S1 is started at 0 degrees and it started conducting for, okay, that means, so it started at 0 degrees and it will conduct for 120 degrees because we are talking about 120 degrees conduction. Okay. So, this is the period for which S1 conducts. Okay, S1 is on for 120 degrees, and for the next 60 degrees, actually in the earlier class we have seen that S1 was conducted for 180 degrees and for the next 180 degrees S2 was conducted, but here for next 60 degrees, that is from 120 to 180, neither S1 nor S2 will conduct, like, so this will be non-conducting region. So that means from A wing there will be no switches conducting in this period here. Okay, so this is non-conducting period, that is 60 degrees. Okay, so after this 60 degrees S2 will start conducting for 120 degrees. So this here S2 will be conducting, and after 120 degrees there will be non-conducting interval of 60 degrees, and again S1 starts conducting. Okay, so this is the conduction scheme for A wing, and let us see for B wing. S3 will start conducting after 120 degrees of S1 started conducting. So this is after 120 degrees, and it will conduct for 120 degrees, and for the next 60 degrees there will be non-conduction region. So this is non-conduction region. After that S4 will conduct for 120 degrees, and okay, so like this. Okay, actually this up to this 360, that means, so S4 will conduct till now and till here. This is non-conducting region of S3 and S4. So S4 will conduct here and here. Okay, now let us see the C wing here. Here we have S5 and S6. S5 will start conducting after 120 degrees from S3. So this is S5 here. Okay, and up to this S5 will conduct, and there will be a non-conducting region of 60 degrees. So this is the region after which S6 will conduct for 120 degrees, and in between there will be a non-conduction region here. So this is the switching scheme for 120 degree conduction. Okay. Now what we are going to see, we are going to see what are the switches that are conducting for 60 degrees period, that is from 0 to 60, 60 to 120, 120 to 180, and the same waveforms will be mirror imaged after 180 degrees. Okay. So we are going to find phase voltages as well as line voltages for three-phase inverter. Okay. So let us proceed. So first we are going to see 0 to 60 degrees. Okay. So what are the switches that are conducting between 0 to 60 degrees? So we can see S1 and S4 are conducting. Okay. So S1 is here, okay, A wing, and S4 is B wing here. Okay. So let us see what is happening from 0 degrees to 60 degrees. So the switches that are conducting are S1, comma S4 are conducting, right? S1, S4 are conducting. So these are the two switches. For 180 degrees conduction mode, which we have seen earlier, there were 3 switches conducting at a time, but for 120 degrees conduction mode there are only 2 switches. Here you can see one switch is odd numbered one, another is even numbered one. That means we have one switch operating from upper group, okay, and other from lower group. Okay, so S1 is connecting our A group and the load is connected in star, so that will be like this. So this is B group. So here we are supplying from plus and minus VDC. Here you can see we can divide the voltage between these two terminals with half polarity VDC by 2 plus and minus VDC by 2, because the impedance will be same. Okay, that means this is VAN, I can write it as, okay, so the phase voltage, I am writing the phase voltage here. Okay, so VAN is equal to VDC by 2, whereas VNB is also VDC by 2, but we need VBN, which is minus VDC by 2 here. So talking about VCN, there is no term for VCN, so let us assume it as 0 volts. Okay, so here we have obtained phase voltage VAN is plus VDC by 2, VBN is minus VDC by 2, and VCN is equal to 0. Okay, so these are the phase voltages for 0 to 60 degrees conduction. Now let us see the line voltage here. So line voltages, okay, so VAB, we know the formula, right, which equal to VDC by 2 minus VDC by 2. Okay, so VAB is equal to plus VDC. Likewise VBC, it is minus VDC by 2 minus 0, like that is minus VDC by 2 VBC. And final line voltage VCA is VCN minus VAN, which is 0 minus of VAN is plus VDC by 2, that will be minus VDC by 2, right. So these are the behavior of phase and line voltage. Okay, so let us draw the waveforms here. For phase voltages, the voltages are plus VDC by 2, minus VDC by 2 and 0. For line voltages, they are plus VDC, minus VDC by 2 and minus VDC. Okay, so let us see, let us draw the graphs here. VDC by 2 minus VDC by 2 0. So I am drawing. So here, so let us draw the phase voltage here. VAN, VBN, VCN, right. So this is the magnitude for VDC, and this is for minus VDC, VDC minus VDC. Okay, so VAN is plus VDC by 2 for 60 to 0 to 60 degrees. Okay, plus VDC by 2. Okay, so VAN is plus VDC by 2. This is plus VDC by 2, and VBN is minus VDC by 2. Half of this peak here. So this is minus VDC by 2, right? So this is plus VDC by 2. This is minus VDC by 2 here, and VCN is 0. VCN is 0 here. Now let us see the line voltage VCA, VAB, VBC, and the VCA. So VAB, so what is the value of VAB? That is plus VDC, plus VDC, and VBC is minus VDC by 2. VCA is VCN minus VAN is equal to 0 minus VDC by 2, which is minus VDC by 2, right? So here VAB is plus VDC, VBC is minus VDC by 2, and VCA is minus VDC by 2. This is plus VDC, this is plus VDC, and this is minus VDC by 2. This is also minus VDC by 2. Okay, here this is plus VDC, and VBC is minus VDC by 2. VCA is also minus VDC by 2 here. Okay, now let us see what is happening for 60 to 120 degrees. So let us see the switches that are turned on for 60 to 120. This is the region here. So here if you observe, S1 and S6 is S1 and S6 are turned on here from 60 degrees to 120 degrees. Switches S1 S6 are conducting. Okay, S1 is from upper group. Okay, S1 is from upper group and it is connected to group A here, A phase and neutral here. S6 is from lower group, it is contributing for B phase here, right? And these are supplied with VDC supply, right? So S6 is contributing our B phase, S1 is conducting A phase. Okay, so now let us see what is happening here. So here the voltage VDC will be distributed evenly, VDC by 2 and plus or minus VDC by 2 here. Okay, so here VAN is equal to VDC by 2. Similarly, VNB is equal to VDC by 2. But we need VBN, which is opposite to minus VDC by 2. Okay, so and here there is no sign for VCN, which is 0. Okay, so these are the things here. So S6 is contributing for C, right? Okay, S6 is contributing for C, not B. This is C here. C. So that means here so VNC is VDC by 2, but VCN is minus VDC by 2 here. But VBN is 0. So VAB is VAN, right? VAN equal to VDC by 2, VBN equal to 0, VCN equal to minus VDC by 2. So these are the phase voltages from 60 to 120 degrees, right? These are the phase voltages. Now let us see the line voltages. They are VAB is equal to VDC by 2 minus 0, VDC by 2, VBC right. This time substituting the values here. Finally VCA. So this will be minus VDC. Okay, so these are the line voltages for 60 to 120 degrees. Okay, just we are calculating phase voltages as well as line voltages, and we are drawing them on the phasor waveforms here. Okay. Okay, so let us draw the waveforms here for phase voltage first. Okay, from 60 to 120 degrees. Okay, so VAN is plus VDC by 2, so there is no change in the value, right? VAN is plus VDC by 2, VBN is 0 and VCN is minus VDC by 2. VBN is 0, VBN is 0 for 60 to 120 degrees, this is 0, and VCN is minus VDC by 2, so this is minus VDC by 2. Okay, so let us see the line voltage here. Line voltage are VDC by 2, VDC by 2 and minus VDC. VDC by 2, VDC by 2 and minus VDC. So this is minus VDC. Okay, so these are the behavior of waveforms. Now let us see for 120 to 180 degrees. Okay, so for 120 to 180 degrees, the switches that are conducting are S3 and S6 here. Okay, from 120 degrees to 180 degrees. So what are the switches that are connecting? S3, S6 are connecting. You can see one switch from upper group and one switch from lower group are connecting. Okay, so S3 and S6. S3 contributing for B phase, S6 contributing for C phase, right? So here S3 contributing for B phase here, and S6 is contributing for C phase. Okay, so S6 neutral point, this is C phase, plus and minus VDC. You can see here the voltage will be divided equally because they are having same impedance, VDC by 2 minus, right. So here the voltage division will be plus VDC by 2 up to this minus and plus VDC by 2, right. So we can write the phase voltage from 120 to 180 degrees conduction. There VAN is equal to 0 VA. There is no presence of A phase. VBN is equal to plus VDC by 2. VCN is minus VDC by 2. Okay, so we have seen that, right? VAB is line voltage between A and B phases, 0 minus VDC by 2, which is minus VDC by 2. VBC plus VDC, right? Final one VCA. And substituting the values here. So these are the line voltages. Okay, so let us draw the waveforms here. Phase voltage plus VDC by 2. VAN is 0, right? So VAN is 0, VDC by 2 and minus VDC by 2. VAN is 0 here. So here VAN is 0 for this time period, 120 to 180 degrees, and VBN is plus VDC by 2, VCN is minus VDC by 2, right? Let us see the line voltage here. Line voltage are minus VDC by 2 plus VDC minus VDC by 2, minus VDC by 2 plus VDC minus VDC by 2. Okay, so these are the waveforms for 180 degrees, from 0 to 180 degrees. Okay, after this, these waveforms will be mirror imaged. Okay, after 180, from 180 to 360, the same waveforms will be mirror imaged, right? Okay, so I am drawing the rest of the waveforms for 180 to 360. Okay, so that will be, so the VAN will be minus VDC by 2 for next to 120 degrees, and it will be 0 for next to 60 degrees, and it will again plus VDC by 2. Okay, so VBN will be conducted for next to 60 degrees in plus VDC by 2, and it will be 0 for next to 60 degrees, and it will again be minus VDC by 2 for next 120 degrees. So likewise VCN will be 0 for next to 60 degrees and plus VDC by 2 for next to 120 degrees, and it will be 0 for next 60 degrees, like this. It will 0 for next 60 and plus VDC by 2 for next 120 and 0 for next 60. So this will be repeated. Likewise VCN will be VBC, VAB, VBC, VCR line voltages. Okay, and the line voltage will be like this. Okay, okay, so here and here the VCA will be like this, okay. So these are the waveforms for 3-phase voltage source inverter for 120 degrees conduction. Okay, so we had seen 180 degrees conduction mode, now we have seen the 120 degree conduction mode. Okay, so this is about 3-phase voltage source inverters. Okay, I hope you understand. Thank you.